So this video is to go over solving quadratic equations by factoring. And there are four main steps when we want to solve a quadratic equation by factoring. So the first step is to make sure that it can be factored. And the way to do that is to make sure that the equation is in standard form. ax squared plus bx plus c is equal to 0. So if it's not equal to 0, we need to do so. And it's pretty simple. It's typically if I have x squared plus x equal to 2, I would just subtract 2 from either side so that it's equal to 0. Once it's in standard form, then you can actually factor that left side typically that is in standard form. We typically use the box method. Once it's factored, then you can apply the zero product rule to find the two solutions. And the zero product rule says if I have a factor A times a factor B and it's equal to 0, then either factor could be set equal to 0. Once we've applied the zero product rule and find the solutions, you always want to check that your solutions are actually correct. And we'll do that using substitution and check both solutions. So let's give this a try. We have the quadratic equation 2x squared plus 5x is equal to 12. And we said that that very first step is to make sure it is equal to 0. Remember, it has to be in standard form where it's equal to 0. And that is not the case here. So I'm going to subtract 12 from both sides because 12 minus 12 is 0. On the other side, I have an x squared, I have an x, and I have a constant. So no like terms, so I just get to quickly rewrite it. 2x squared plus 5x minus 12 equal to 0. Now I'm ready to factor this left-hand side, which is step 2. So for step 2, the first thing that you want to do when you're factoring is to list out A, B, and C values so that you can complete a X puzzle or sum and product puzzle. So standard form, A is in front of x squared, so in that case 2. B is in front of x, which is a positive 5. And our C is our constant, which is a negative 12. The X puzzle, the top is A times C, so 2 times negative 12 is negative 24. And we want to find two values that multiply to be negative 24, but add up to our B value of 5. So I'm going to make a list of values that will multiply to be 24. So I have 8 options. I have 1 through 4 where the 1 through 4 are negative, or I can do the same pair but where the higher number 24, 12, 8, and 6 are negative. And I want to find the pair that adds up to a positive B value of 5. And that would be negative 3 and 8. Okay. So now I'm ready to actually do factoring, and I like to use the box. And with the box, your original first term 2x squared and the last term negative 12 can fill in the first box and the last box. But then 5x, the middle term, is going to be split with those magic numbers we found, negative 3x and a positive 8x, because negative 3x plus 8x does add up to 5x. Okay, so with factoring, we like to pull out the GCF of each column and row. So 2x squared and negative 3x have a GCF of just x or 1x. 8x and negative 12, they're both even, but one is positive, one is negative. So I can only pull out that positive even number. The highest number that goes into 8 and 12 is 4. For the first row, 2x squared and 8x, they both have at least 1x, and 2 and 8 are both divisible by 2. Negative 3x and 12, they don't both have an x, so I'm not going to pull that out, but they are both negative, and 3 and 12 are both divisible by 3. So my factors of 2x squared plus 5x minus 12 are x x plus 4 and 2x minus 3. And I can still set it all equal to 0, which is going to lead me to step 3. So I've rewritten the original equation, and remember we set, which was 2x squared plus 5x equals 12. Then the first thing we did was set it equal to 0, and then we factored it. These are all equivalent, but we're now at this factored step, which means I can apply the zero product rule. And the zero product rule says if I have two things that are being multiplied and equal to 0, I can split them up and set each factor equal to 0 and solve each individual equation. So I can split this up and say x plus 4 is equal to 0 and 2x minus 3 could be equal to 0. And I can solve each side individually. So x plus 4 equal to 0, I'm going to subtract 4, which gives me x equal to negative 4, which is one of my solutions. On the other side, for 2x minus 3 equal to 0, I'm going to add 3, which gives me 2x is equal to positive 3. Then I'm going to divide by 2, which gives me x is equal to 3 halves, or you can also say x is equal to 1.5. And that is my second solution. So now I'm ready to check my solutions. So with our step 4, where we check the answer, we want to make sure that both of the solutions, x equals negative 4 and x equals 3 halves, makes the original equation, which I have down here in the bottom, 2x squared plus 5x equal to 12. We want to make sure it makes them true. So I'm going to work on the first solution to see if it works. So I'm going to take the original equation, and wherever there was an x, I'm going to substitute in that solution of negative 4. Then I'm going to follow PEMDAS, which says negative 4 squared is a positive 16. And I can go ahead and do positive 5 times negative 4 is negative 20. Then 2 times 16, which is 32. And 32 minus 20 is 12. And 12 does equal 12. So I know my first solution of x equals negative 4 is correct. Let's try solution number 2. So our second solution of 3 halves, I'm going to go ahead and plug it into the original equation. PEMDAS says to do this exponent or power of 2 first. When you're dealing with fractions, you square both the numerator and the denominator. So 3 squared is 9. 2 squared is 4. I'm going to carry down the 2. With fractions and multiplication, with 5, I just have to multiply at the top. 5 times 3 is 15, and carry the 2. Remember, you can always use a calculator, and there's an online calculator, desmos.com, which can be really helpful. Okay, so then another multiplication. 2 times 9 is 18. Keep the denominator 4 and 15 halves. And then I have to add those fractions, but to add fractions, I have to have common denominators. So I'm going to do a quick side work here. Times 2 and times 2 will give me 30/4. And now I can actually add these. 18 plus 30 is 48. Keep the denominator. 48 divided by 4 is 12, which means 12 is equal to 12. Therefore, 3 halves is my second true solution. Thanks for watching.